you have to calculate the empirical formula by adding the atomic mass of all atoms present. Sometimes reactant will be consumed completely in the reaction. That time you can expect only little bit of product. Aqueous solutions means whatever the reactions or solutions done by the water itself, we'll call it as aqueous solution. You are converting into simplest whole number, that is only empirical formula. Again you have to write it down for molecular formula. Hello everyone, this is Harshita Bhavasar from Vidhyaashram PU College, Temple of Excellence in Mysore. So today we'll start with the session 4 of chapter Some Basic Concepts of Chemistry. In the last session, we have discussed about dimensional analysis, law of chemical combinations, Dalton's atomic theory and mole concept and molar mass. These are the concepts we have discussed in the previous session. Today's session will discuss about what is percentage composition, empirical formula, molecular formula, stoichiometry and its calculations, limiting reagents, reactions in solutions, expressing concentration of solutions. These are the contents today we are going to discuss, and also with some numericals. First we will see percentage composition. What is the meaning of percentage composition? How we can calculate the percentage of the given compound? We will see now. Percentage composition of a compound is the relative mass of each of the constituent element or in 100 parts of it by mass. Okay. We are going to calculate the percentage of each element in the given compound. For that, we have to see the relative mass of the each constituent element that will represent the 100 parts of it by mass. We will see the formula. Percentage of an element will be calculated by mass of element in the compound by molar mass of the compound into 100. Percentage means we have to calculate by 100, that we know, but what we have to calculate? Mass of the element in the compound by molar mass of the compound. We will see first example. Water is a compound. See here, molecular formula H2O, molar mass of water is 18.02. How it become 18.02? Hydrogen will be 1.008. The 2 molecule is present. That's why 2.008. And for oxygen, 16 is the atomic weight. That's why after calculating, you will get 18.02 gram. See here, mass of percentage of hydrogen. Of each element, we are finding the mass of percentage, mass percentage. So 2 molecule is present. So 2 atomic weight is of hydrogen is 1.008 divided by overall molar mass of the compound. What is that? 18.02. For that, into 100, you will get 11.18. Similarly, you have to find out mass percentage of oxygen. For oxygen, what is the atomic weight? 16. How many molecule is present? Only one oxygen atom is present. For that, divided by molar mass of compound is 18.02. Again, you have to find out into 100. Overall, you will get 88.79. This is a very simple way to calculate the percentage composition. Okay. Once again, percentage of element can be calculated by mass of each element, means mass of any single element will be divided by overall molar mass of the element into 100. Why 100? We are finding out the percentage. That's why we have to calculate into 100. Next, another example. What is the percentage of carbon, hydrogen and oxygen in ethanol? What is the molecular formula for ethanol? C2H5OH. First we have to see the molecular formula. Later only we can find out its percentage composition. How many carbon? 2. How many hydrogen? 5 plus 1, 6. And oxygen is 1. That's why 2 into atomic weight of this one carbon, 6 into atomic weight of hydrogen. This is only one oxygen. Overall, you will get molar mass is 46.068 gram. Now we are finding out the mass percentage of carbon. Like we did in the previous problem, like that only 12 into 2, 24.02 by overall molar mass of compound into 100. You will get 52.14%. Next, mass percentage of hydrogen. See here, 6 into 1, 6.048 gram by overall molar mass into 100, 13.13%. Later, mass percentage of oxygen. How much? 16 by overall molar mass of compound into 100, 34.73%. Like this, you have to find out the mass percentage of each element given in the compound. Next, we will see empirical formula. The simplest whole number ratio of the atoms of various elements present in the one molecule of compound. The simplest whole number ratio of the atoms, the whole number of the atoms present in various elements present in where molecule. You are seeing the whole number ratio of atom in element present in the one molecule of compound. Okay, that is known as empirical formula. Example, in glucose there are 6 carbon, 12 hydrogen and 6 oxygen atoms. That is why molecular formula C6H12O6. How we are finding out? CHO, this is ratio you have to write 6:12:6. Again you have to convert it into simplest whole number, that is 1:2:1. Like 6 1s are 6, 6 2s are 12, 6 1s are 6. You are converting into simplest whole number, that is only empirical formula. Again you have to write it down for molecular formula. Examples here, 1:2:1. Like that you have to convert the simplest empirical formula in the simplest whole number. Another example, in hydrogen peroxide, that is H2O2. Ratio of number of atoms of hydrogen to oxygen is 2:2 or 1:1. See here, 2:2, or you can write it in a simplest way, means 1:1. Like this you have to write the empirical formula. If you doesn't understand this way, there are so many steps to understand how to calculate the empirical formula. Calculation of relative number of atoms or atomic ratio. First you have to see the atomic ratio, that is percentage of an element by atomic mass of the element. Percentage, how you have to find out, that you know now, by atomic mass of the element. Okay. After that, calculation of simple atomic ratio. Divide the atomic ratio obtained in step 1 by the smallest fraction. By the smallest fraction, you have to divide whatever you will get here, the number. This gives the simple atomic ratio. Okay. Next, calculation of simple whole number ratio. If it is in this step, whole number ratio is not obtained, then round off the values of the nearest number. If you will get 16.08 or 17.01, you have to round off. This one will become 16, this one it will become 17. You have to round off to the whole number. Okay, multiply all the simplest atomic ratios by a suitable integer. You have to multiply. Like that, you see here, you are multiplying the simple integer. 6 1s are 6, 6 2s are 12, 6 1s are 6. Like this, you have to multiply and you will get this number. Write the empirical formula using the above simple number whole ratio. That is what we did here. Again, after simplifying or we getting the simplest whole number, you have to again enter for the molecular formula, that is C1H2O1. Like this you have to enter after getting the empirical formula. This is how the calculation of empirical formula will be done. Next, molecular formula. The actual ratio of the atoms of various elements present in one molecule of the compound. The various atoms will be present of element in one molecule. Those things you have to find out, will be called as molecular formula. Calculation of molecular formula. Calculate the empirical formula mass by adding the atomic masses. What masses of all the atoms present in the empirical formula? What they are telling? You have to calculate the empirical formula by adding the atomic mass of all atoms present. First you have to find out the empirical formula that you have seen in the previous slide. Again for that you have to add the atomic masses of all the elements present in the compound. Okay. Determine N. N equal molecular mass by empirical formula mass. Next, molecular formula will be empirical formula into N. If you want to find out molecular formula, that time you have to cross multiply this one, empirical formula into N. Then vapor density into 2 will be molecular mass. These are the simple formulas to find out the molecular formula. Next is stoichiometry and stoichiometric calculations. Stoichiometry, the word stoichiometry will be given by the Greek words, that is stoichion means element, metro means measurable. Okay. Once again, the stoichiometry word was given by two Greek words, that is stoichion means element, metro means measure. Stoichiometry thus deals with the calculation of masses of reactants, masses and volume of the reactant and the products involved in a chemical reaction. Stoichiometry means it is a measurement of the element present in the chemical reaction. In the chemical reaction, what are things will be present? Reactants and products. In reactants, masses will be present or volumes will be present. If some case, both will be present, mass and volume. Both the things, mass and volumes present in reactant, mass and volume present in product, those both things you have to find out. That finding out of the both things we will call it as stoichiometry. Let us consider the combustion of methane. This is the example. A balanced chemical equation for this reaction is given by CH4 2O2 CO2 plus 2H2O. Okay. What it is giving? Methane and oxygen is getting reacted. It will form carbon dioxide and 2 molecules of water. Here methane and dioxygen are called as reactants. Whatever methane and dioxygen are given in the form of reactants, and carbon dioxide and water are called products. Note that all the reactants and the products are gases in the above reaction, and it has been indicated by letter G in the brackets next to this formula. Similarly, in the case of solids and liquids, S and L will be are written respectively. Whatever you are seeing here G, that is states of matter they are indicating. If it is G, that is gases. If it is small s or L, that is solids and liquids respectively. Here why they are returning means, when you are read the equations, chemical equation, you should know how the states of matter was given. If water is given in G, that will be known as steam. Or if water is written as L, that is in the form of water. Or water is given in the form of S, that is in ice form. Like that, by seeing the state of matter, you will get to know what kind of liquid or what kind of substance they are using. When the state of matter has been changed, that overall chemical reactions also little bit changed with respect to the nature of matter along with the chemical you have used. So many chemicals will be used in the different nature of matter for the compatible with the reaction. Okay. Next, the coefficients 2 for O2 and H2O are called stoichiometric coefficients. Similarly, the coefficients for methane and carbon dioxide is 1 in each case. See here, they are given 2 for oxygen. That time you have to note that number only. If nothing is there, example before the CHO nothing is there, that time you have to consider the stoichiometric coefficient will be 1 for both the things, methane and carbon dioxide. They represent the number of molecules taking part in the reaction or formed in the reaction. Whatever it is behind the compound, that will be how many molecules are involved in the reactions if it is in a reactant, or how many molecules are given out from the reaction if it is present in a product. That is number of molecules in the compound. Thus, according to the chemical reaction, 1 mole of methane reacts with 2 moles of oxygen to give 1 mole of carbon dioxide and 2 moles of water. What they are giving? If it is in a mole form, you have to write like this, in a mole. And if it is in a molecule, same thing you should tell in a molecule. Or if it is in a number of molecules or liter, again you should represent the same thing with the volume. Okay, this is in the mass. What they are telling means, from these relationship, the given data can be interconverted as follows. It can be written as mass, moles and number of molecules. Okay, the overall reaction will be interconverted into mass, moles and number of molecules. That's why the same reaction has been written out in the various kinds. See here, mass by volume is density. This is the important formula you have seen in your previous classes also and this class also. Next is, we'll see an example problem. How many moles of methane are required to produce 22 gram of carbon dioxide after combustion? According to the chemical equation, CH4 plus 2O2 gives CO2 plus 2H2O. This is the reaction. You know that what they are asking for 22 gram of carbon dioxide. 44 gram of carbon dioxide is obtained from 16 gram of methane, right? Then therefore 1 mole of carbon dioxide is obtained from 1 mole of methane. Number of moles of carbon dioxide is equal to 22 gram of carbon dioxide into 1 mole of carbon dioxide by 44 gram of carbon dioxide. These data we know. This data they have given, that's why we are multiplying with whatever we got the data. That's why you will get 0.5 mole of carbon dioxide. Hence 0.5 mole of carbon dioxide would be obtained from 0.5 mole methane would be required to produce the 22 gram of carbon dioxide. Whatever we know the data that you have multiplied by the, they have given the required data. Next is limiting reagent. The substance which is totally consumed when the chemical reaction is complete, the amount of product formed is limited by the reagent since the reaction cannot proceed without it. What does it mean? The whatever substance which is totally consumed by the reaction, when the complete amount of product is formed by a little thing, means limited by the reagent. Okay. Since the reaction occurred, proceed without it. Chemical reaction cannot be proceed without the limiting reagent also. But it will be, by using limiting reagent, the product will be given as a limited way also. Those are the properties of limiting reagent. A reactant that completely reacts in a given reaction is called limiting reagent. That is the reactant which gets completely consumed in a reaction. Limiting reagent decides the amount of product formed in a reaction. As I told already, without limiting reagent, you cannot proceed the chemical reaction. But sometimes reactant will be consumed completely in the reaction. That time you can expect only little bit of product. But how much product it should be given out will be decided by the limiting reagent. Example, in the reaction, manganese oxide is reacting with 4 molecule of hydrochloric acid, which will give MnCl2 plus Cl2 plus 2H2O. If MnO2 is the limiting reagent and the number of moles of MnO2 will be N0 MnO2, then number of moles of MnCl2, Cl2 and H2O formed are equal to N0 MnO2, N0 MnO2 and 2 MnO2. Like this you have to calculate. If HCl is the limiting reagent, what you have to do? N0 HCl. See, they are changing out the limiting reagent and you can find out based on the what they have given the limiting reagent. Here if you consider MnO2 is a limiting reagent, you have to write this formula like this. If you consider HCl is the limiting reagent, that time you have to show like this. Next, overall the moles of MnCl2, Cl2 and H2O are equal to N0 HCl by 4, N0 HCl by 4 and N0 HCl by 2 respectively. Based on this only they are telling. Next, reactions in solutions. Most of the reactions carried out in the laboratory occur in aqueous solutions. Aqueous solutions means whatever the reactions or solutions done by the water itself, we will call it as aqueous solution. A solution is a homogeneous mixture of 2 or more substances. Usually, the component present in a smaller proportion is called the solute and the component present in the larger proportion is called solvent. We know that if it is a beaker, any liquid present here, that is in a larger proportion, that is solvent. Whatever we are adding to dissolve in this solvent, that will be in a smaller proportion, that we'll call it as solute. After mixing up, it will form solution. Right? This is smaller proportion we are using in solute, and adding to the larger proportion of solvent, it will form overall solution. This is the reaction will be seen in solution. What are the terms we'll express to identify the concentration of solution? We'll see now. Concentration of a solution can be expressed either qualitatively concentrated or used to describe a solution qualitatively. To see how much solution is qualitatively present means what are the concentrations are present in the solution will be expressed in so many terms. First we'll see mass percentage. Mass of the solute in grams present in 100 gram of the solution will be call it as mass percentage. Means mass of solute by mass of solution into 100. Whatever for the solvent we are using, how much of solute you have to write here, divided by overall mass of solution into 100. If you calculate, you will get mass percentage. Example, a solution is prepared by adding of 2 gram of substance of A to 18 gram of water. Okay, see here, this is 18 gram of water. You are adding 2 gram of A. Okay, now what you have to find out? This is solute. 2 by 18 into 100 means mass percentage of A overall 20, because 18 plus 2 overall 20 into 100, if you get 10%. Okay. Next is mole fraction. Ratio of the number of moles of a particular component to the total number of moles of component of solution will be 1. In a binary solution containing a solute and in a solvent. See here, mole fraction will be designated by X solute is X solute by number of solute plus number of solvent. What will happen? Same thing you will find out here. Mole fraction and the mass percentage is little bit same, but here you are finding out number of moles, ratio of moles present in solute and solvent with overall solution. Now we will see about molarity. Okay, molarity will be designated by big M. So what is the meaning of or the definition of molarity? Means number of moles of solute in 1 liter of the solution. In normality we will see the number of equivalents. Here in the molarity we will see number of moles of solute in 1 liter of solution. Okay, to find out the molarity, this is the formula: mass of solute by volume of solution in liter. M equal to M by V. Okay, that is molarity formula. Here again we can write it as mass of solute per liter by molecular mass. This also we can write. For calculation purpose and in the experimental way or the doing the calculations of molarity with having the comparative version, that is concentrated to dilute solutions, when we are converting into concentrated to dilute, that time we can use this formula. M1 V1 into M1 V1 equals M2 V2, where M1 and V1 are the concentration and volume of the concentrated solution. Okay, M2 V2 are the concentration and volume of the diluted solution. Okay, once again I am repeating. The statement of molarity is number of moles of solute in 1 liter of the solution. For the calculation purpose, we will use M1 V1 equal to M2 V2. M1 V1 are the mass and volume of the concentrated solution, and M2 V2 are the concentration and volume of the diluted solution. Okay, if you want to find out the molarity, see, if the molarity of 0.05 concentration of 200 ml, if you want to dilute for 0.01 molarity for 100 ml solution, this formula we can use. This is M1, this is V1, this is M2, this is V2. Okay. Next, how could 100 ml of 0.125 molar H2SO4 solution be made from 0.500 molar H2SO4 solution? This is dilute. This is concentration. Concentrated. From this concentrated, how can be made dilute for this molarity in 100 ml? Same here as I show 0.125 100. You want to do for this V2 equals 25. Okay. That is 25 ml of 0.500 molar H2SO4 is needed to prepare for 100 ml of 0.125 molar H2SO4. It is also be noted that the number of moles of solute remains unchanged. The units of molarity will be molar. Here the number of moles of solute will not change, but the quantity will be changed, that's all. The molarity will be designated by small m. Next is normality. The number of grams equivalents of solute present in a liter of the solution. Here number of gram equivalent of solute divided by volume of solution. Same thing, N1V1 into N2V2 is the equation to be used for dilution related calculations involving normality. Molarity and normality is same. Their number of moles you are calculating, here number of equivalents you are calculating. Next is parts per million. That will be written in ppm. Number of parts by mass of solute per million parts by mass of a solution. See here, ppm is mass of solute by mass of solution into 10 to the power of 6. This one you have seen in mass percentage, but there 100 you have put. Here 10 to the power of 6 you have to put. That time you can find out parts per million. Okay. I hope you have understood whatever I have taught today. This completes your first chapter, that is some basic concepts of chemistry. Thank you so much.